So this is the second in the movies on how to use the NCCA point bake system, and what we're going to concentrate on now is loading it in C++ and using the NGL classes to have a look at what we can do with it. So first of all, if we look into the NGL library itself, you'll see there's this point bake class here. It lives within the NGL namespace. The documentation here is worth reading. It just sort of gives you an idea of the format, how it all works, and everything else. And we've got methods, constructor with a file name. We can set the active frame. This is to be used when we're doing sort of meshing style stuff. We can load in a new point bake file. We can load a binary point bake file. As I said, there is a method to load in a point bake and then save it out as a binary file. We can do that, so we load in the XML once, then we just save it out as a binary, which means next time we're basically just loading in the raw data. It's going to be a lot quicker. There are a couple of little filter programs that come with NGL which will allow you to do various bits with that. We can attach a mesh to it. Now this is quite important. Basically, when we load in an OBJ within NGL, what happens is that the vertices are reordered in such a way that we try to share as many vertices as we can to reduce space, and then we create a VBO out of that data, which is then loaded into OpenGL and used. So the format of the data, the vertices, normals and texture coordinates, are not necessarily in the same sequence as they are in the OBJ file if we were to just sort of go through and use the OBJ face structure. So when we attach a mesh to the point bake data, typically that mesh is going to be drawn using the VBO data, so we need to actually reorder that data and so on, and we'll see in a little while in the point bake source file it will go through and reorder the data so it's in the same format as the mesh data we use later. And if we're going to use point bake in conjunction with an OBJ, we need to do this. We can then set the mesh to a particular frame, so we can basically modify the mesh to get the animation in. Then we've got a series of accessors, get number of frames, get number of vertices. We can get a raw data pointer, so that's basically going to just return the raw data, and we'll see later in the next demo how we use this. We can get the raw data at a particular frame, and we can also access the reordered data, which is basically as I said with the mesh previously. Now the data itself, you'll see from this, is stored as a vector of vectors. So this is the core of this class. Here we've got a standard vector of standard vectors of NGL vectors. So it's an array of X, Y, Z, W points, and that's then an array of those. It's most probably not the most efficient of storage, but it's the most convenient, and obviously it will expand. So it works, and I'm going to stick to doing this. So we've got a mesh here, which is the raw data that will be loaded when we construct it. Sorry, M data there of our point bake data. We also have the option of creating the reordered data, which is generally larger than the raw data loaded in because it's been reconstructed as per happens with when we load in the OBJ. We've then got a series of other methods and attributes in there, nothing particularly special. We're using the QXML stream reader because Qt's got its own XML library built in, so I thought we might as well just use that. I have been considering moving away from XML and moving to using JSON, mainly because it's going to take up slightly less space. I haven't considered that fully yet, but this may change. The principles won't change, just we may have different data formats, and it should be quite easy to extend to use both anyway. That will be future work. So basically the code, we load in our data, we use the Qt XML elements, so we create a stream reader here. We look for our different elements, start elements. If we've got a start element, it might be mesh name, number of verts, start, end, number of frames, so on. You can see once I find the number of frames, I can go in and resize my data. Double resizing, so first we resize the outer array to the number of frames, then we go in and we resize the inner arrays to the number of vertices. That's now reordered everything to the size that we need. Then once we find the vertex data, we can actually go in and set that data, as you can see there. So we go in, set it all, and it should all be ready to use. Here's the code to write out binary data and read in binary data, set the mesh to frame. So this actually will map our mesh that we've created. Here, map the VBO vertices, which are basically stored in the mesh itself on the VBO once it's created. Then we go through and we take our reordered data and we set the VBO GPU side stuff. So that's how we can mutate basically the mesh. This is the code to do the reordering of the vertices here. So it just goes through and uses the same algorithm as used in the OBJ. If you're interested, have a read of that. We attach the mesh, some basic checks to see that they can be attached, and then we reorder the vertices and do it all there. And this is just the accessors to get the raw data. So it's actually a relatively simple class. So what we're going to look at now is this demo program here, which is going to load in an OBJ mesh and the point-baked data, and then as you can see it's playing back the animation, slightly slower than the Maya version was previously, but we can modify that a bit later, just get the speed right. But you can see it's the same animation data, same mesh that's going through from both of the objects there. So the first thing we're going to do in our class is this is a standard sort of NGL demo that I've gone through many times before, so I'm not going to worry too much about the sort of larger code base. What we've got here is in our GL window we have got an NGL OBJ, which is going to be our mesh, and we've got an NGL NCCA point bake, which is going to be our animation data. And what we're going to do is load our mesh first. We are then going to load our animation data. We're then going to attach our mesh to the animation data, and then every frame we're going to go and update things. So first in GL window, what we can see here, usual again initialization code that we use for most of our other demos. So first thing, we're going to load in our mesh. So mmesh equals new NGL OBJ, and I've got my shark.obj in the models directory, and that will load that in. Next we're going to create our VBO so we can draw it. So that's just reordering the vertices, packing them in such a way that they can be loaded to OpenGL. We get a VBO object back from it and we're ready to use it. Now I'm going to grab the point bake data, so same sort of thing. Anim data is a new NCCA point bake. It's models shark.xml, which is a file I showed you previously. This one here, shark.xml. So all of this data will get loaded in and stored in our point bake model. Then a little bit of basic housekeeping. First, set our start frame to 0. Then I'm setting anim data. I'm attaching my mesh, so that will attach the mesh to the model ready to start working. And I'm setting my global frame to 0, enable multi-sampling, starting my animation timer. So the animation timer is going to click every so many milliseconds. So if I set that to a lower value, we should get a faster swim rate for our shark, for example. Let's just load all the data. There you go. So most probably as fast as it can go because of the remapping of the vertices. So we've started that. So in PaintGL, this is the function that's called every frame. I'm just calling mesh draw because we map our vertices, we update them on the VBO. We basically just need to draw the mesh. We can draw the bounding box as well. You'll notice the bounding box doesn't actually resize because that's taken from the raw data of the OBJ and not from the bounding box. So you can see that that doesn't recalculate, hence that was commented out. The only other thing is every time the timer event clicks in, we increment the frame, make sure it's not greater than the number of frames, otherwise we'll set it back to 0, and we set mesh to frame, which will go off and update the animation mesh, ready to draw the next one. And you can see that as this runs, load in the frame, that looks like it's about to crash. Yes. Must have a memory leak somewhere. There we go. That was weird. And yes, that's about it. It's a very, very simple process. So I'm going to stop there on this one. The next demo is going to show you a slightly different way of loading in data.